Am I audible? And is the screen visible? Okay. Where are the rest of the students? There are only 25. Kindly tell them to join as soon as possible. See, all your presence is getting recorded. Remember, if they ask for it, I have to provide it to them. It is not our typical register-based attendance system. Please be there. I repeated the same thing to the B1 people also. Even if you are not liking it or you are feeling tired, at least log in and listen. And lest I cannot say as a teacher, please, Professor Raja, come up. Tell others to be there. Shall I start? It's only 29. It's 31, 32. A few more is needed. Please be there. Everything is getting recorded, please. And this is like compulsion for us. It may not be asked, but if it is asked, then nobody can defy something that has been recorded. Please, आप लोग आ जाओ, please. Tell the rest of the guys to be present. So let's start with the next chapter of ours, that is expert systems, right? So in the part, the topics in this expert system part are in the introduction and knowledge acquisition, the knowledge base, the working memory, the inference engine, the export system shells, uh, the remaining explanation part, its application areas, and so on. Right. We'll start up with what is an export system. An understandable definition of what an export system is. It's like you can call it as an human computer interface, like HCI kind of a tool that is interactive and it is computer based. Basically, it is a decision making tool, and it is based on both facts as well as heuristics for making decisions and solving problems, and uh, providing with certain amount of knowledge and information uh, has been gathered from an expert to that particular user, right? So basically, an expert system is a kind of a tool that is associated with the procedure that exhibits within a specific domain our degree of expertise in problem solving that is comparable with that of a human expert. Remember, let us now check for its explanation a bit. Generally, what happens that each one of us, we have got an expertise in one thing or the other, right? There are a lot of skills or abilities that are not just restricted by the information that are available only in the books or in any other medium. But we gather this expertise over a period of time by solving a certain kind of problem again and again. And by doing so, we get the idea of tackling any diverse kind of problems of similar nature, right? So by doing so, over the period of time, any individual becomes an expert of that particular specific domain, right? Now that information may not be available with a normal uh, interactive or learning system. So what can be done is this expertise of a human expert's knowledge can be, if it can be encoded in a computer-based tool, then that thing can be regarded as an expert system for that particular domain that has been trained by that particular individual, right? So an expert system can be compared with a traditional computer as, like, an expert system can be an inference engine with a knowledge base, then we can call it as an expert system. In our older or in our traditional way, we can call it as an algorithm with a data structure. It gives us the program in traditional computer-based programming platforms. Now, whenever we talk of it, is like a monotonous thing that whenever people start talking about an expert system, then the word dendral comes up instantaneously. This dendral is supposedly the first export system that was developed way back in the 1970s in the Stanford University. Now, uh, let us see what are the in-depth ideas about an expert system. Straight away, we can say that an expert system is something that provides an information or helps in making decision, or they provide with a solution on the basis of preset rules or expertise that are encoded within that particular system. So, in a way, we can call it that they are generally non-algorithmic processes. That means there is no fixed algorithm for them. They are totally rule-based applications or rule-based tools. So, for example, expert systems can play chess, or they can make financial planning, or they can give you financial decisions, or they can help you in making financial decisions. They can configure the computers, or they can monitor any kind of real-time systems. They can talk about the insurance policies, rules and regulations. They can perform some of the services that previously required human intervention. Right now, before we even move further, we need to know the expert system components and human interfaces. So this is the diagram of a typical expert system. It comprises basically of the heart of the export system is the knowledge base, right? The heart of the export system is the knowledge base. We do have a working memory or a secondary knowledge base, we call it as the working storage. Next, we do have an interface engine that interacts both with the knowledge base as well as with the working storage. At last, we do have the user interface with which the individual is using this particular export system interacts. Right? Now, other than the particular user, we do have a domain expert, we do have a knowledge engineer, and a system engineer. Now, this who's this domain expert? A domain expert can be anyone from a particular or a specific domain. Like that person can be from a financial domain. He's an expert from the financial domain. He may be an expert from the tech domain, like he may be a cybercrime specialist, or he may be someone like who's a medical expert, like he may be a doctor or a surgeon, right? And the next one is a knowledge engineer. What he does is he encodes the expertise of this domain expert into a knowledge base, right? He encodes the expertise of this domain expert into a knowledge base, right? There is another individual. There is another individual. He is the systems engineer. What does the system engineer do? He takes care of all these three tiers of the expert systems architecture. In the first tier, we do have the knowledge base and the working storage. The second tier, we do have the inference engine. In the third tier, we do have the user interface. Now, in all, we do have four segment of human who are involved in utilizing the expert system as well as in maintaining the expert system. Out of these four individuals, two may be clubbed up. That means this knowledge engineer as well as the system engineer can be a single person depending upon that how big my expert system is. If my expert system is supposedly large enough, by the term large, I mean it is big enough to be handled by a single person, then we need specific person for being the knowledge engineer as well as for the system engineer. But if the expert system is a small one, then we can have a single person who can play the role of both the knowledge engineer as well as that of the system engineer. Let us see the individual components and their roles one by one. Now the components and interfaces of the expert system. We do have first the knowledge base. As I have already said, it is the declarative representation of the expertise, often in the form of if-then rules. That means it is just the set of if-then rules that are encoded by the knowledge engineer as he has extracted the information from the domain expert and has encoded them, right? We do have the working storage. Now, this working storage is the data which is specific to the problem that is being solved. That means out of all the information that is there in the knowledge base, a particular set of information gets utilized for solving a particular problem at a particular point of time. So the whole of the knowledge base is not utilized. So we can say that working storage or the working memory is the part that utilizes a segment or a part of the overall knowledge base. In the inference engine, we do have the code or we do have the system architecture that is a kind of place where the decisions or the inferences or the deductions are made. That means we infer further knowledge from the rule base and the working storage and come up to a kind of solution that helps in problem specific data and its working storage, right? Next comes as the user interface. This is nothing but the interface where the user who is using the expert system is present there, right? Now comes the roles of the individuals who interact with the system. The first one is the domain expert. He is the individual who I have already said who currently are experts in solving that particular class of problems. Here the system is intended to solve, right? So he is basically from that particular domain He's basically from that particular domain of problem which is being solved by that particular expert system. We do have the knowledge engineer. I have already said he's the individual who encodes the expert's knowledge in the declarative form that can be used by the experts. The user is someone who uses the yes. Now comes the fact that what are expert system shells? Uh, you may forget a lot of things during examination, but some of the things are to be remembered by heart, right? So the moment somebody talks about expert system shells, you must immediately talk about the knowledge engineer and the system engineer. Here, what are the things that are left out? Here, what are the things that are left out? The things that are left out are the domain expert and the user. So out of the four individuals who are involved in the functioning or in the utility of the export system, we are taking up two people who maintain the export system, the knowledge engineer as well as the system engineer. They are the two people who comprise for the export system shells. Right? So as I've already said that depending on the size of the system, the knowledge engineer and the system engineer might be the same person also. Now we do have the expert system characteristics. There are a few set of characteristics that are typical for any particular expert system. Now what are those characteristics? The characteristics are that they must be an interactive system. They must operate as an interactive one. That means they should be somewhat like an HCI, human computer interface kind of a stuff, which the users can use in a very handy way, right? Now, there should be tools. There should be tools which has got the ability to filter the knowledge, shift or filter the knowledge. there must be there must be logical inferences based on the stored knowledge, right? So this is my third characteristics of a expert system. The expert system should also have the ability to explain the reasoning. Whatever reasoning is being provided by the expert system, whatever reasoning is being provided by the expert system, they must have the ability to explain those reasonings, right? Now comes the domain specific. That means this is the most important characteristics. This is one of the most important characteristics of an export system. All the export systems, they are mostly domain specific. That means they are particularly related to a domain. They are related to a particular domain. Now, the next one is the capability to assign confidence values, right? With applications and cost-effective alternatives to the human expert. These are the characteristics, right? So let us see all of them one by one. If we talk about that how interactively an expert system operates, then there are a few points that are to be noted. Obviously, if it is an expert system and if it is a replica of a human expert, then it must respond to the queries of the user, right? It must respond to the questions or queries of the user. If that is understandable, then it is fine. If not, then the expert system can ask for further clarifications, right? The expert system can ask for further clarifications. After going through the queries and making further and taking up the further clarifications from the user, they can make recommendations. That means they can put forward their decisions, right? They can put forward their decisions. This whole process helps in making the decision process for which the expert system is meant for. Next comes the tool. Now, they must have the ability to filter the knowledge. That means the storage and the retrieval part of the knowledge, they must have the mechanisms to expand, update the knowledge base on continuing basis. That means any expert system shell's knowledge base is not restricted and it can keep on enhancing over a period of time, right? We can keep on adding newer and newer knowledge to that particular export system. Now comes making logical inferences based on knowledge stored, like simple reasoning mechanisms, or the knowledge base must have a means for exploiting the knowledge stored, else it is useless, right? So they must have the logical inferences for the information that has been stored inside the knowledge base as well as in the working memory part. Ability to explain reasoning. Here, as I have already said, now it remembers the logical chain of reasoning, right? Therefore, the user may ask for explanation of the recommendation that has been made by the ES. If the ES has said something, then it must be prepared to explain that why they have taken that particular reasoning. It enhances user confidence in recommendation and acceptance of the expert system. The higher will be the ability to reason for a particular ES, the better will be its output and more confidence can be shown by the user for that particular expert system. Domain specific. It is clearly and loudly said that almost all the export systems that are available are highly domain specific. That means they are meant for a particular way. They are meant for a particular domain. A particular system caters a narrow area of specialization. What do this statement means? You will always find expert system that is related to a particular domain, a specific domain. Let's say there is an expert system for medical diagnosis. So that expert system will be giving us the uh, giving us the decisions for what kind of disease a particular patient is having, or they can be for financial decision making. They can ask for your income, to which income group you belong, what is your age, what is your source of income, and all these questions may be asked, and on the basis of that it can recommend you that how much amount of money you can save at a particular time or you should save, and these kind of suggestions, or for any particular market based expert system, like what should be the area in which I should invest, these kind of things, this kind of ES can be developed for a particular specific domain based system, domain based areas, right? Now the next one is the capability to assign confidence values. Here I'll take you back to this part. That means make recommendations and aids in decision making. This was the part of interactiveness of the expert system. This was a part of interactiveness of the expert system. I'll again take you back after I wanted to just read and remember these two lines, like making recommendation and aiding the process of decision making. This thing becomes more helpful when we do have the capability, or the ES has got the capability to assign confidence values, right? The ES has got the capability to assign confidence values. The higher will be the confidence, that means the higher it can deliver the quantitative information, the higher will be the person's reliance or person's belief on that particular expert system, right? Let's say I'll cite an example at this point of time. A typical, medical diagnosis based expert system in which, let's say, there are a lot of questionnaires, like you might have seen, even though I'm not saying it's an expert system, but some of its part, they act as an expert system. Uh, I'm talking about the Arogya Setu app that is there. In the Arogya Setu app, you'll be finding that there are a lot of questions that are asked, that what are the chances that you can contract the disease of COVID or not, you do have a travel history or not, or how frequently you go out, what is your age, you do have kind of previous ailments or not. All these things are properly assembled and these things are analyzed, and then at the end it has been said that no, fine, you are healthy enough and you've got very less chances of contracting this disease. These kind of decision making parameters are based on the confidence value. Now, these kind of things are based on confidence values, but the output that are given is like you've got very less chances. You've got hardly 1% chance of contracting the disease, right? That means you're 99% safe. These kind of values are called as the confidence values. That means with how much confidence expert system is giving you its decisions, right? Next comes the application. They are best suited for dealing with expert heuristics for solving the problems. That means they pick up the heuristics process of a particular domain expert, and that is encoded within that particular ES for application purpose. They are basically not suited for problems which can be solved by pure numerical techniques, because here you don't need any kind of heuristics. You don't have any kind of heuristics involved here. In the previous, that means in case of ES, we need a heuristics approach because we are encoding certain skills or abilities of a domain expert which has been gained over a period of time on the basis of his experience and not on the basis of clear cut assertions that are made by the numerical techniques, right? The next characteristics is that of the cost effective alternative to human expert. As we have already known that for any individual, let's say if he's a cybercrime expert or if he's an ethical hacking expert, if or he's a medical professional or he's a very fine systems engineer who knows about the rocket sciences, these kind of experts they charge mammothly for their particular expertise what they are having, or even if he's a financial expert, if he's having a very good idea about the financial domain, then they charge a lot of money. If the information can be encoded into a computer system, then that thing can be rendered to its users free of cost. Yeah, we understand that they are restricted to a very narrow field. They are for a very specific domain, but still they are highly helpful, right? So, encoding and storing a domain-specific knowledge is economic process due to its small size. Specialists in many areas are rare, and the cost of consulting them is really high. An expert system in those areas can be useful and cost-effective alternative in the long run. Now we do have the expert system. We do have the expert system features. The feature which commonly exist in the expert systems are they are basically goal driven, or they are basically backward chaining based, or sometimes uh, one of the features is coping with uncertainty. Right? What do I mean by coping with uncertainty? It is the ability for the system to reason for the data that has not been clearly mentioned in my knowledge base. That means you have to fill the voids, how to deal with the voids or the uncertainty in the information that has been provided. Right? Then comes the forward chaining. We had the backward chaining, we have the forward chaining. I will not be talking about what they are, but obviously I'll be talking about their particular application areas. They are mostly the if then rule segment that are for application purpose. Another feature is that of the data representation, the way in which the problem-specific data in a particular system is stored and accessed, right? The user interface. This has to be good enough because an ES is specifically meant for a particular user, right? Who can use the system so that he can use the system properly. Next comes the explanations, the ability of the system to explain the reasoning process, how he has come to a kind of a decision or how he has given a particular knowledge. So the reason behind that particular decision making has to be clearly said to a particular user. Now, each of these features are in the same detail. Right? In the previous lectures. Uh, okay. Now here we do have this goal-driven one. And that means we do have the goal-driven process. We do have next the uncertainty, and then we do have the data-driven one. Right? The small examples, very small examples. I have got a dedicated YouTube lecture on this for the for the BY guys. They have gone through it. You may also go through that part if you wish, or I can even talk about this yourself, right? Uh, if you wish, I can talk about that now. If you wish, I can talk about that now. Should I? Yes, better I should. To those of you, should I talk about it? Should I give you the idea for this? The forward chaining and backward chaining? Is it needed? I can do it very fast, by the way. Even if you've gone through it, it can be a kind of a revision. Kindly respond. Should I do that? Okay. Are you all people sleeping out there by keeping the phone beside you? It's a good time. It's around 4:40. You can keep it beside and you can sleep. You're writing yes, sir. That means you're sleeping. And even if you're sleeping, how come you're writing yes, sir? Okay, now Chandan Kumar's notes are good enough, right? Thanks for saying at least a no. At least I've got one no, two no, three no. It feels good when you say a no. Chala, let me talk about this part. So I'm sorry, these are all my handwritten notes, so you may find a little difficulty in reading, but still it will help you out to a greater extent. You can just go through it once. Now, while we are talking about the search strategies, right? Then the related terms in the search strategies are condition action rules. This is the term that you need to remember. The condition action rules means if then rules. इसको हम कहते हैं, we call it as the condition action rules. It is out here, right? The condition action rules. And the next one is the forward and the backward chaining. So we are comprised of, the first thing that we are comprised of are the rules, and the second one is that of the chaining. We are just going through this part, right? We are just going through this part. Now, first one is the rules and second one is the chaining. Now the condition action rules is one way of encoding the knowledge. We had seen out here, right? We had seen out here that how in an expert system a domain expert's expertise is encoded, right? How a domain expert's expertise is encoded. So the condition action rules is the one way of encoding this particular knowledge, right? These rules are written as if there is some condition, then there is some action for that condition. If there is some condition, so there is some action for that particular condition. Some of the examples are like rule number 1, if it is a red light, then stop. If it is a green light, then you can go. So this part is the antecedent part. So this whole part, I just made a rectangle out here. This whole part is called as the antecedent part, and this whole part is called as the consequent part. You can even call this part as the premise part, or you can call this part as the conclusion part, right? So this part, and I'm just telling you, you just say it to yourself once so that you can remember it during the exam. This part is called as the antecedent part, and this part is called as the consequent part. This part is called as the premise part. This part is called as the conclusion part. Hey, you can see this cursor, right? You can see this cursor moving. This one. You can see this moving at your end. You're seeing this moving, right? Yes or no? Or else it will use this for me to, to hover over the screen at all point of time. You can't see this. You can't see this one. This cross mark. This cursor you can't see. अरे यार, ये भगवान. I was also thinking of it. Okay, forget about it. I'm talking. Okay, I'll be keeping that thing on the top of the slide, right? जिस part को मैं बता रहा हूँ, that thing will be on the top of it. So I do have the antecedent part. I do have the consequent part. I hope you can read it out here. And then we are coming down to chaining, right? Sharing conditions between multiple rules so that the same condition is evaluated once for all rules. If somebody asks about what is chaining, it is like sharing the condition between rules so that the same condition can be evaluated once for at least all the rules, right? So the conditions can be chained when they are shared between multiple rules, right? So the chaining can be of two types. The first one is the forward chaining, and the second one is that of the backward chaining. Now, in case of forward chaining, it is basically data driven. It is called as data driven. In case of backward chaining, it is basically called as a query driven. Kindly, I've written a few lines out there, like one sentence I've written within the square brackets. I hope you can read it. Don't get confused with the forward and the backward searches, right? I'm talking about the forward and backward chain. Don't get confused with forward and backward searches that we've already done in the classes, right? Now comes the activation of rules. In case of activation of rules for forward and backward chaining are the strategies of activation of the rules in the system. The forward and backward chaining, they are nothing but the strategies for activation of the rules in the system, right? These activation helps in drawing the inference. So in fact, I can say that activation rules are a process by which we can draw the inference in the working memory part, or they are basically a part of the inference engine, right? Now we'll be talking about what are these inference rules. Now, the moment we talk about the inference rules, we say that the first inference rule is the deductive inference rule, DEDUCTI, deductive inference rule. I hope you can read it properly, right? So, in case of under inference rules, we can have the deductive inference rule. Deductive inference rule is nothing but my forward chaining. So, if somebody asks about what is the deductive inference rule, it is nothing but exactly similar to that of the forward chaining itself, right? So, I can see an example for that. In case of forward chaining, you can see here, like conclude from A, just read it, conclude from A to B, conclude from A out here to B, don't read the center part of it, read at the end, conclude from A to B, and by the process of A implies B in between, right? So you have to start up from A, you have to reach for B with a central implication of A implies B, with a central implication of A implies B. I hope you can see it here, with the central implication of A implies B, right? So you'll be reading it somewhat like this: A, conclude from A and move up to B by A implies B, right? So there's a small example for that. It is raining, right? You do have it is raining. If it is raining, then the street is wet. I'm reading about, I'm just going through the second part of it. So if it is raining, the street is wet, right? And so finally the street is wet. So it is raining and up to the street is wet. I'm going through this part, right? In case of initially what we had the deductive inference rule. Now we do have the abductive inference rule. We do have the abductive inference rule. What is this abductive inference rule called? It is nothing but the backward chaining, right? This abductive inference rule is nothing but the backward chaining. Now, what do we do in this? Now, conclude from B to A with A implies B, right? That means start up with B, reach up to A by applying A implies B. Here, the reverse of it, that means the street is wet and we have to go up to it is raining. Now, since the street is wet and it is raining, hence the street is wet, so we can conclude that it is raining. So now we are coming down to the FCA, or the forward chaining algorithm. Forward chaining algorithm is basically for drawing the inference from the rule base. It is basically for drawing the inference from the rule base. So forward chaining inference is basically data driven. Forward chaining inference is basically INFE RENC, this is inference. What is the algorithm for it? Now start with a given situation. And move towards the desired goal by keep on adding new assertions or facts that are found. You have to start up with a given situation and then move towards a desired goal by adding new assertions or facts that are found. Now, what is the next thing that you got to do is you have to compare the data in the working memory with the if conditions and decide which rule to fire, right? And decide which rule to fire. This is the typical example we do have. That means we have initially started with the data and we ended up with the conclusion. We have certain things to be done in between. The rules are applied and initially our data is given and we need to conclude that b equal to 4, The only thing that you need to remember that the flow of the data is in this direction. That means the flow of the process is in this direction from the left hand side to the right hand side. Now we'll be talking about the forward chaining problem. This is a very small problem. It's already there in your slides. I'm just giving an explanation for that. Like a very hefty, algorithm has been provided. Instead of that, you can go through a very easier one. Right? Now, given a set of rules, you're provided with a set of rule base that contains the following rule set. What are the rules? Now, you're provided with rule 1, 2, 3, and 4. Now let us talk about one of the rule one by one. Rule 1 talks about if it is A and C, then it is F, right? So rule 2 talks about if it is A and E, then it is G. Rule 3 talks about if it is B, then it is E. Rule 4 says if it is G, then it is D. And we are taking care of what? Now we are taking care of the forward chaining part. What do you got to prove? Now if it is, we have to prove that if it is if A and B is true, then D is true. First, I'll talk about the way in which this problem has been dealt in the slide itself. So the solution starts with a given input A and B. Because since it is forward chaining, I'll be starting up with this. That means the first initial data, and I'll be moving for the conclusion part, right? So I'm having the A and B out here, and is true, then start with the rule 1 and go forward down. I'll start with the rule 1 and go forward down. Down means I'll be moving in this direction, right? Go forward down till a rule fires is found. Now what I'll be doing here is I'll be going on with the first iteration number 1. So what I'll be doing here, I'll be picking up any one of these data that has been given to me, A or B, and I'll be checking one of them. Is it there? A is there, but there is another part in the premise. That means in the antecedent part, there is another one, that is C is there. Again with A, this is there. But for my B, there is one rule that is there, that is rule number 3. It talks about if it is B, then we can get a E here. So I'll be stuck up with rule number 3. It fires conclusion E is true and a new knowledge is found, right? Now go further down. That means I have come up with rule number 3. I'll be coming up with rule number 4 now to go for if there is G or D. So this rule will be fired. No, this rule will, no further rules can be fired. See, it is there. No further rules can be fired. So this is an end of first iteration. This is an end of first iteration. Now check for the goal, and if it is not found, then you can carry on. New knowledge is found in 2 again. That means in the second rule. What is there in the second rule? Since you are having A and from B you have generated E here from rule number 3. So in the second iteration, when you're coming down in your knowledge base, you are having A, you are having B, and you're already having E since E has been added. So now you can go for rule number 2, that means A and E, and you can generate G here. That means in the second iteration, rule number 2 will be fired, and now you will be having what are the various information that has now been generated. Now, other than A and B, you are having E as well as G out there. You will be having E as well as G out there, right? See, rule number 4 and conclusion, D is there. Now, when it has been fired, then what you got to do is, since you have got G, so from G you can fire in that iteration itself, that is in the second iteration itself, you can go for firing of the rule number 4 and you can generate D here. So now D is generated, hence it is true and we have proved it, right? So this is one of the way, and hence it is proved. There is an alternate easier way also. There is an alternate easier way also to what I have said. The same things are here, like in case of rule 1, we do have AC gives F, and then if it is A, then it is G. If it is B, and then it is E. The same things are there as we had. The only thing is that in case of forward chaining, there's an arrow you can see here. It goes down from the top to the bottom, and what you got to prove is if there is A and B, then you got to prove that there is D, right? So initially, what is the data that you're having? Initially, you are having A and B. This is there in your working memory, the added knowledge that has been already provided. So you are having initially the given data, that is A and B, and gradually over a period of time you will be adding further knowledge to it. Right? Just a moment. There are 44 people out here. आज कौन अटेंडेंस लेने वाला है? बाय द वे, हर्षित पुरवार लोगे क्या? Harshit, would you take the attendance? ओके, हाँ अगम आप ले लो। हाँ, अगम हर्षित दोनों ले लो, अपने पास रखो, किसी का खो गया तो दोनों रख लो, ठीक है? दोनों कर लो, मैं नोट कर रहा हूँ, लेकिन है ना, आज के डेट के साथ आप तो देखे हो मैं अपलोड भी करता हूँ, एंड आई नोट डाउन दैट हु इज टेकिंग द अटेंडेंस। आप इसको रखोगे एंड विल बी शेयरिंग इट विथ मी लेटर। नाउ after the first iteration, what is happening is you are adding E by rule number 3. So you're already having A and B here, and then with that you have added up a E here in the first iteration. So in the second iteration, what else you're doing? Now G is getting added by rule number 2. You are just going down over the rules, right? In the second iteration, first iteration rule number 3 over, in the second iteration rule number 3 will not be used again, so rule number 2 and 4 is left. So you are adding G by firing rule number 2. You're going down, 3 has already been fired. Now you're gone up to rule number 4, which has given you D. So you have added up D. The moment D is there in my this whole knowledge base, that means now I know that it has been proved. So I have put up that it has been proved. So to sum up, we iterate the rules from the top to the bottom, and from left hand side, right? Now start with the given data and keep adding the new knowledge. Now stop when one can include the RHS to prove in the new knowledge, right? If you can add the RHS in the new knowledge, what is this RHS? This RHS is nothing but this D here. The RHS is nothing but the D here, right? What is the catch is? Catch means, what is the thing that you need to remember, that which rule to pick. Which rule to pick depends on what is the thing that you have to prove. That means here you have to prove D, and the data that is provided is A, that is you have to check either A or you have to check either B, or you can check A and B together. So in the set of the rules on the left hand side, right? You can ask for any kind of questions is there. Now comes the backward chaining. इसको मैं आपको next class में बताता हूँ. आज के लिए it is more than enough. चलो, enjoy your Sunday. Bye. Take care. If is the attendance over, Agam and Harshit? Okay. चलो 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 ठीक है, चलो चलो, you can leave the meeting. Bye. Take care. Bye.